All right, so a couple things off the top. So I put up a couple announcements yesterday. One, I reminded everybody these top hat questions, because we're having Wi-Fi issues that apparently are not going to get resolved. Every class, I'm going to post the questions that we go through in class as a separate top hat assignment that needs to be completed before we meet in class the next time. Okay? So even if you answer in class when I'm showing you the questions, you don't have to, right? We're working through them in class, and then you need to answer the questions for these new top hat assignments. So if we go to top hat here, we can see, not just putting them, well, of course I forgot to, there we go. Scroll down here. That's what these kind of additional assignments are. They're now set to review because the due date is passed, but they'll appear like homework assignments, right? So these should be really easy effort points. As long as you get on and get these done, I'm giving you the answers in class. You should be able to get all the points, okay? So if there's any confusion, I mean, I feel like I've said this, but right, in the announcements, even if you answered them in class, everyone needs to go on after class and answer these questions, okay? Also, we go to Canvas. So I put up another announcement. For a handful of you, it's not even 10%, I don't think. Your grades from Packback aren't syncing up. So the reason why your grades aren't syncing up, and I mentioned this week one, so I understand that was easy maybe to forget. The first time that you go to Packback, I said to make sure you're accessing it through Canvas. If you want to afterwards, just type in packback.co and do it that way, that's fine. But it doesn't sync up to Canvas if you don't click this link. Now you can do it even though the assignment is passed. You can still kind of get this to sync up. If you're not seeing your Packback grade on Canvas, you need to go to Canvas and click this Packback link. That'll kind of connect the two, and then your grade should start syncing from Packback. So you'll see your grade on Packback. If you're not seeing it on Canvas, it's because you haven't clicked that link yet, right? So if you haven't, make sure you do that. Other than that, I don't think I have any other housekeeping stuff. So this week, you won't have a module reading because what's next Thursday? First exam, right? So it's coming quick, right? It's like every 4 modules, we're going to have an exam. So this is the 4th module. So with all of this week's materials, you'll kind of notice I put, where are they? Down here. A practice exam as well as an answer key. I don't know how much of this we'll have time to work through next Tuesday, but on Tuesday's class next week, essentially, I'll just be going through a lot of these problems. It'll be like a review class. I highly recommend being here Tuesday, right? These questions are very representative of what you'll see on the exam. And there's a strong positive correlation between attendance in that review session, which I generally, even if I don't use it for points, take attendance just because I'm curious, right? And also performance on the exam, okay? Now, you still do have a quiz this week, a module 4 quiz. So you've got the practice problem for that module as well. CL sessions as usual, right? Other than that, any questions for me before we dive into material here today? We're good? All right. So we'll finish up. We didn't quite get through all of module 3, but that's okay. We got plenty of time this week. So we talked about equilibrium shifts. What did I want to get to? I want to talk about, here we go. So we talked about thinking about where equilibrium was where that supply intersected demand, or at that point, at that price, the quantity supplied was the exact same as the quantity demand, right? We're at the same point in terms of quantity on both of those lines. So if instead, I'll show you a graph here. So if instead of being at this price of $3, where the quantity demanded, the point we were at in the demand curve, and the quantity supplied, the point we were at in the supply curve was 15, we said we were in equilibrium. There was the exact same number of units being produced and put out there on the market that were being purchased. If instead I had a higher price, where at that price, quantity demanded is going to be a little bit lower, right? If I increase the price, people don't want to buy as much. But at this higher price, what are producers willing to do? Buy more to the market. So here, if we have prices above the equilibrium, we end up with this quantity demanded being less than the quantity supplied. There's more units than people want to buy. This is called a surplus, right? So think of things like surplus stores, right? We've got more units than people wanted to buy, and so we're just trying to get rid of them. Okay? So you can kind of look at that from a supply schedule standpoint as well. So instead of the visual, and I'll go back, I'll draw a graph with that again. But if we're looking at this supply and demand schedule here, where would the equilibrium be? Well, where does supply equal demand, or where does the quantity supplied equal demand? Right here at 15. So that equilibrium price is 3. If instead, we had a higher price of 5, we said people are going to want to demand less, right? Demand falls from 15 to 9. Producers want to supply more because they can sell this good for a higher price. So they would want to supply 25 units. Quantity supplied is greater than quantity demanded. So we would have a surplus. And the value of that surplus is how many additional units do we have laying around? If 25 are produced, only 9 people want to buy them. How many units do we have? 16 laying around, or our surplus value would be 16. Okay. So anytime quantity supplied is above quantity demanded, we've got a surplus, right? And the difference between quantity supplied and quantity demanded, that simply will be our surplus. Okay. Another visual to kind of go along with this, and we'll add to this as we go. Is it hot in here, by the way? Like insanely hot, right? Okay. Getting worried that I was like this me, or I hope I'm not getting sick. So we've got supply, demand, just to kind of be good practice. We remind ourselves, demand represents marginal benefits, supply represents marginal costs. So anytime, here's our equilibrium price. Anytime we have a price that's above our equilibrium, what is always going to be true about every single price in this range? The quantity demanded is less than quantity supplied. So every single price in this range, we've got a surplus. So you can kind of think about if the price varies from that equilibrium price, if it tends to be higher, then we end up with a surplus. More people want to supply the good than people want to buy it. Okay. Any questions on this idea? So jump the gun a little bit since we've got this drawing already up here. What do you think happens if the price is anywhere below the equilibrium? Well, lower prices, what's going to happen to the quantity demanded? It's going to go up. What's going to happen to the quantity supplied? It's going to go down. So notice that any one of these prices, what's true about my quantity supplied relative to my quantity demanded? It's less. Right? So anytime we've got a quantity supply that's less than our quantity demanded, here we say we've got not a surplus, but a shortage. There's more people that want to buy this good than there are producers willing to supply it, right? We don't have enough goods to kind of satisfy demand, if you want to think about it that way. So just to kind of be complete, up here in this range, what was true? Well, there, when the price was above the equilibrium, quantity demanded was less than quantity supplied. This is when we had a surplus. When did this occur? When we had prices that were above the equilibrium. And when did the shortages occur? Whenever we had prices below our equilibrium. Any questions on anything here? This is kind of a lot here, quick, but we're thinking about these supply and demand curves just represent the different quantity demanded and the quantity supplied at different prices. We know that when quantity demanded and quantity supplied are exactly the same, that'll be where the market settles in the long run, or that will be our equilibrium. But in the short run, we might very well see the price be higher or lower than that equilibrium price. Now you can imagine if there's a surplus, if the price is too high, well, if I'm producing units and there's no one to buy them, what am I going to start doing? So if people aren't buying a good, what do you think happens to those companies? Some of them go away, right? What happens if we see a kind of reduction in how many of the companies? Well, there's lower quantity supply, right? If no one's buying the good, I'm going to supply less. So the fact that there's this kind of surplus, there's going to be pressure that pushes that price down. Because the price is so high that there's just not enough people that want to buy the goods we're producing, we're not going to produce as much, right? We're not making any money off those just because the price is high. If I can't sell the good, I'm not making any money, right? So there's this pressure if you have a surplus for that price to be lowered until every unit that I'm producing is now being purchased by somebody, right? Until we hit that equilibrium. Now, if for some reason the short one we start out at a price that's too low, Well, now we've got, pointed the wrong thing. Now we've got a shortage, right? Okay, so if more people want to buy this good than what is currently being supplied, what do you think suppliers will do? Enter the market, or existing companies will start to produce more, right? Then as they produce more, right, they only will do so at higher prices. Some people will stop wanting to buy the good at those higher prices, and there's upward pressure on this price until we get to this point where there's no longer a shortage and we're at that equilibrium price. So kind of, we haven't really talked about short, long run, but sort of introduce this idea because we will really hammer it down in later modules. But, we might see prices that are at the equilibrium in the short run. We know that in the long run, eventually, as we allow this market to kind of operate, we'll end up at this equilibrium price, right? And the reason why is because if there's a surplus, I'm not just going to produce goods if I can't sell them, right? So I'm going to, reduce how many I'm producing back down to the price. If there's a shortage, well, there's a lot of people who want to buy this good, and I'm going to start putting more out there on the market. Okay. Any questions before we kind of go back to the slides here? Okay. All right, so there we go. So we kind of already worked through this. I mentioned this already, right? As we have this surplus, people want to, if I'm not selling the good, we start to, supply less and less in the market. More and more people, as we lower that price, are going to be willing to buy until we get down to this equilibrium point. Okay, so we kind of already talked through this. So when there's too much demand, not enough supply, right? That's when we've got, what do we say? Shortage, right? More people want to buy the good than they want to supply it, right? So shortage, it's very similar. We can look at the supply schedule. We don't have to look at it in graph form. So if I'm looking here, let's say, let's give an example. I'll kind of talk about this later on. Let's say the government comes in and says, I don't know, the price of insulin is way too high. So if the price of insulin is way too high, and they're like, okay, we don't think people should be paying this much, we're going to artificially lower the price. We're telling companies they can't sell it over a certain price. Well, what's going to happen? So let's say that equilibrium price is $3. $3 doesn't make any sense in terms of the price of insulin, but just go with me for I don't know why I chose insulin today. But you got one as being the price the government is setting. Well, now at that lower price, how many people want to buy this good? People are willing to buy a lot more. Insulin's kind of weird. So, well, you need insulin. Well, maybe you try to stretch out what you had before, right? Not use as much, even though the doctor will tell you that's not good. And so we would have at this lower price a quantity demanded that's much greater than the quantity supplied. We said if that's the case, we have a shortage, and the value of that shortage is just the difference between that quantity demanded and quantity supplied at that price, right? Visually, it was kind of that difference between our supply and demand curve at whatever price we were looking at. Okay. Any questions? Yeah. So it's here, we're not talking about any kind of shifts in supply or demand. We're just talking about changes. So the things that shift demand were things like supply, things like changes in income, changes in the number of supply, all these things. Here, we're just talking about the relationship between the price of the good and the quantity demanded or supplied of that good itself. So movements along these curves, not shifts. Yep. Yeah. Nope. So we're talking about shortages and surpluses in the number of units. Like, I won't do this, but you technically could say, well, what's the value of the shortage or surplus, right? It gets a little bit tricky because you can value at the current price, but you know that over time the price is going to, well, in this case, shortages, the price will eventually rise. But yeah, you could put a dollar amount to it by simply multiplying that unit difference by whatever the current price is. All right, but we're not going to go into that. We're just talking about surpluses and shortages in terms of the number of units. It's the difference in quantities. Does that answer your question? Any other questions here? All right. I've already drawn this out for you, but anytime we have a price below that equilibrium, we said our quantity supplied is going to be much lower than our quantity demanded. So here, what would our value of our shortage be? Quantity supplied is 5, quantity demanded is 20, 15, right? So, actually, sorry, it's 21. I'm looking at this a little bit off, right? So yeah, not 15, but 16, right? The difference between 21 and 5, not 20 and 5. Okay. So I don't think that's, I think terribly tough. These shortage surplus should be somewhat, I think, easier even than like the shift stuff we were doing last week. And then I already mentioned we have these shortages. There's then pressure on the price for, if I've got way more people that want to buy this good than are currently being produced. Well, in order to supply more to the market to meet that unmet demand, I'm going to have to do so at a higher price because the marginal cost of every unit past 5 here, remember supply represents marginal cost. I'm only willing to supply these units to the market if the price gets to be exactly equal to or above that marginal cost. So in order for us to see an increase in the quantity supplied, the price is going to have to rise. As the price rises, fewer people want to purchase the good, and this kind of pressure continues. There you go, all the way until we get to that equilibrium point. Okay. Any questions on this side? So maybe this is not like the most technical way to remember it, but when we're talking about surpluses and shortages, you're identifying things based off of like horizontal differences, right? You're looking at this price, what's the quantity supplied and what's the quantity demand, right? We're not going to be comparing, say, the price, the point we're at in supply and demand at a single quantity. We're comparing where we're at on supply and demand at a specific price. I bring this up, we'll kind of put this here. How do these happen? Like, even if we look at the long run, how can markets experience surpluses and shortages? Because we know that they exist, right? Quite often, it's an artificial price setting, right? So it's when we don't allow the market to operate freely and at will. So for instance, in the 70s, they capped oil prices. We see this with some drugs. So they'll cap prices on drugs. And initially, you might think, well, that's great, right? So my insulin example, they say, you know what? You currently are charging, I don't know, $100 for a vial of insulin. Diabetics, like they don't have a choice, type 1 diabetes, you're born with it. We don't think that's fair. So we're going to say you can't charge any more than $20. Well, what happens? At $20, what happens to quantity supply? So if I was currently at a price of 100, the price falls to 20, what's happening to quantity supply? It's going to go down. So what's happening? Quantity supply goes down. Even if quantity demand only went up a little bit, right? Because insulin kind of people need whatever amount they need. We're now going to have a shortage. So by setting these artificial prices, initially you might think we're helping consumers. Like if they stepped in tomorrow and said, grocery prices, I hear politicians sometimes talk about this stuff where it's like, oh, we're going to lower food prices. We're going to cap how much you have to pay for, I don't know, a gallon of milk. Well, guess what's going to happen? The producers, if you lower the price, are going to do what? Put less out there on the market. And so what's then going to happen? You've got a shortage. So we see these artificial prices create shortages in markets that were currently in equilibrium. You can also think about one where, and this gets kind of weird, but I'll start to introduce it throughout the semester. Let's say, I think this is worth doing. I think it's interesting and also really hammers home this idea. So let's say here, I'm going to do a weird one. I'm going to think about the quantity and price of labor, right, of workers. Now, generally, we think about the price of labor as like wages, right, or how much you're earning. You think of like how much you're making per hour. You want to think about that way, hourly pay. So we would have some supply of labor. People are willing to work more at higher wages, and then companies, right, if they have to pay higher and higher wages, they're not going to want to hire as many workers. So we can think about there's some equilibrium number of workers, and the market will settle at some equilibrium wage. What does the government do for a lot of low-paying jobs? How many of you have ever got paid under the table? Yeah, I was going to say, I'm in that group, right? So the reason why you're doing that is because if you have to pay a higher wage, if everyone followed the law and paid this higher wage, a minimum wage, what's going to happen here? So the government comes in and says, look, people are being paid too low per hour, whatever their dollar amount per hour is. We think that no worker should make less than, I don't even know what the current, is up like, I'm so far into this, like $12? No? 7 something? Yeah. So I doubt there's a whole lot of wage. So if I do set that minimum wage, right, what's going to happen? At that higher wage, the demand for workers is going to do what? Be a little bit lower. at that higher wage, what's going to happen to the quantity supplied? Well, if the wage is higher, more people are going to work. What have I created? Quantity demanded is less than quantity supplied. What's the surplus of workers? Unemployed, right? And so by setting these minimum wages higher, as long as they're binding, as long as there's jobs out there that would, or really would settle at a wage below that, you're helping the people who keep their jobs out, but the people that lost their jobs are like, I don't care about that. I don't have a job anymore, right? So by artificially setting these prices, we end up out of this equilibrium, right? So I always gonna like this example because, I don't know, it has a lot of real world kind of relevance here. We should think about being very careful about setting prices, right? Either too high or too low, okay? Any questions on this before we keep moving? And I won't ask you any questions about a labor market. I'll simply ask you about like if they're setting the price too high or too low for just our normal goods, okay? All right, I think that covers everything. Yeah, from module 3. The only thing that I didn't do is we could do this with equations, okay? So here I've got my supply and demand equation. I'm just gonna write them down real quick before I switch over. And we're gonna say, how can we determine just with the supply and demand equation what the surplus or shortage is if the price was set at $60? Okay. So here, I wrote these down. Okay. Which of these is my demand curve? Yeah, how do you know that? Yeah, it's always going to be downward sloping, so my slope is going to be negative for my demand curve. So I might do something on the exam where I say, here are the supply and demand equations. I don't tell you which is which. You need to use the concept of the fact that the demand curve is always downward sloping, knowing that the one with a negative slope is going to be your demand curve. But we said the price of our demand curve, right? We said we're going to set that price, and actually the supply curve as well. The government comes in, sets the price at 60. Do we have a surplus or shortage? Well, what would the quantity supplied be at 60? I've got one equation, one unknown. I've got a little bit of algebra to do, but I can solve that, right? So I'll subtract 60 from both sides. Move the 5Q over to the other side. Divide both sides by 5. And I can get this quantity of 8. So this is just solving this equation for the thing we don't know. At that price of 60, what would the quantity demanded be? Now, I can do the same thing for supply. What would the quantity supplied be at a price of 60? Well, 60, here we've got, subtract 20 from both sides. Divide by 15. This is going to be what? 2 2/3 if I'm doing math in my head correct, right? Here's my quantity supplied. Here's my quantity demanded. So what do I have here? Surplus or shortage? Quantity demanded is higher than quantity supplied, so I've got a shortage. There's fewer units being produced at that price than there are being demanded. Okay? And then the value of that shortage would just be the difference between the two. You see all this? Any questions over anything here before we keep moving? Okay. All right. So if there's no questions on that, we'll kind of, yeah. Yeah, so last class we saw for the equilibrium price, we would just set these two equations equal to each other and then solve for that quantity. Yep. If I do that, what do I know? If I've got a shortage here, what do I know has to be true about the equilibrium price? It has to be what relative to 60? We said we only had shortages. So if you think about where is quantity demanded greater than quantity supplied, that's going to be at prices that are below the equilibrium. So what it has to be true about the equilibrium price? Greater than 60. And you can go through, we did it last class. We worked through these exact same equations and solved for that equilibrium. I don't remember what it ends up being. 80 over 20, 40. I think the equilibrium price ends up being 80 if I'm looking at this. I'm doing math in my head quick, which is never safe. Okay. So any other questions on this before we jump into module 4? Okay, where we at? Exactly where we want to be. All right, so we're now going to dive into module 4 here. So we're going to talk probably mostly today just about demand. And we know that demand is downward sloping, right? We're going to talk about this week is something called elasticity. So another word for elasticity you think about is just the responsiveness of something. So when we talk about like something that's elastic, what do you think of? Rubber band. That's the one I always think, right? It's how responsive is that, right? But I don't know. You guys are all young. Maybe I don't know. We work out. I don't know. You go to the gym. They always have like exercise bands. They have different strengths, right? Some are more elastic than others. Right? So this is the idea of the price elasticity of demand is how responsive is demand to changes in something. So how responsive is a rubber band to the change in the force applied to it? How responsive is demand to changes in the price? Because we know when the price changes, demand will respond to some degree, but how responsive, right? That's what we're going to try to measure, okay? So we'll specifically measure this, price elasticity of demand, in terms of percentages, okay? So you kind of think about why. Let's say I increase the price from $1 to $2. That's a pretty large percent increase. I've doubled the price, right? It's increased by 100% there. So if then, that price change, people buy, 10 additional units, well, that was a pretty large price change. But if they were going from buying 1,000 to 1,010, that's a really small percent change, right? Demand didn't really respond that much. Now, on the flip side, if we change the price, same dollar, but go from 99 to 100, that's a very small percentage change. And then if people say change the amount they're buying from, I don't know, 100 to 90, just still that same 10 units. Well, that's a much larger percent change than going from 1,000 to 1,010. So we don't care about just the number of units or the number of dollars the change was. We care about the percentage. So once we have those percentages, the way that we'll calculate price elasticity of demand is what was the percentage change in our quantity demanded relative to or divided by the percentage change in price. So it's a unit-free measure, right? So we can compare across different goods what goods are more or less elastic. So I think here, I've just got a very easy example. Let's say Netflix, as they all have been the last few years, are increasing their prices, right? So if they increase their prices by 50%, and as a result, they see that people, they raise the price, we automatically know that people are going to buy less. So the reduction in subscriptions or memberships that they see is 25%. So you would take that percentage change in quantity demanded, negative 25%, divided by that percentage change in the price, which is 50%, we end up with an elasticity of negative 0.5. Now, it's tricked a few people on the module reading, but it said it in the text. We start out, I'm just starting out, we walk before you run. I'm showing you how you would calculate this. When we talk about the price elasticity of demand, see, there we go. We always take the absolute value. We ignore the negative sign because we know that the price elasticity of demand will always be negative, right? When I increase the price of something, I know people are always going to buy less. And then it makes it easier in the way we talk about things to compare different elasticities of goods. And I think we'll see this here in a second. So we're dealing with negative values, then like greater than is actually closer to 0. And it's kind of more confusing to compare across different goods. And so we always take the absolute value when calculating price elasticity of demand. Okay. Any questions on this before we keep? So we know that relationship is always negative because we know that demand is downward sloping. We just ignore that negative sign essentially. Okay, so that's what those bars mean. Means drop the negative sign, take the absolute value. Just out of curiosity, how many of you have heard of the term absolute value before? A lot. Okay, I'm just making sure. I don't know what they're doing in high school math classes and things these days. So, do I want to go through this yet? Yeah, we'll talk through the midpoint method, and then I'll kind of make some more statements about elasticity. So I just want to kind of make sure we're okay with the calculation. And then we'll talk more about how do I actually use these values to like understand this good, right? So what we're going to do to calculate these percent changes is not quite technically correct, but it makes the math easier for this class. And so that's what we're going to do, right? So we're going to use the midpoint method, which is whenever we see a change in the price or a change in the quantity demanded, we're going to find what that change was and then, right, divide it by the average of those. So if I'm going back here, let's say I saw a price decrease from $100 to $80. You know, I generally think about that's a 20% change, but if I go from 80 to 100, that's 25. We don't want to be doing that. We're moving between like the same, we're on the same portion of the demand curve. We're moving between the same 2 points, just in different directions. So we want to make sure we have the exact same elasticity measure for that portion of the demand curve, for the portion between a price of 80 and 100, no matter which direction we're moving. So what we do is use this midpoint method where I'll look at the percentage change in the quantity demanded, divide it by the average of whatever 2 points I'm moving between, and then I'll divide that by the change in the price divided by the average price of wherever 2 prices I'm moving in between. Okay? So you can think about here, this numerator still represents a percentage change. Written out a little bit more, there we go. So if I'm writing like a change in something, it's just what quantity did I start out at? What quantity am I now at? That was the change in my quantity divided by the average. Well, how do I find the average of 2 numbers? Yeah, I add them up and divide by 2, right? So that's all we're doing here, right? We're taking that change in quantity, dividing it by the average of those 2 values. We're taking that change in price, dividing it by the average. This is going to give us percentage changes in our numerator and our denominator. Okay? So I might have it in the slides, but we can kind of think about what is this going to look like. So where's my, we just said our elasticity measure is going to be take the change in our quantity demanded, and I'll write this a little bit differently. See another visual. Divided by the average of those 2 quantities, and then divide that by the change in the price divided by, not quantity, by the average of the price. Right? So if I'm moving in between $80 and $100, doesn't matter in which direction, what would that denominator look like? Well, my price of 100 minus the other price of 80, so that was the change in the price, divided by the average. Now here, if I give you nice, easy numbers, by all means, do this math in your head, right? So what's the average of 180? 90, right? But to be complete, if these numbers were a little more difficult for me to envision, I would do something like that. And then at these various prices, I would have some quantities and I would do the exact same thing. So let me see if I gave you some of the slides. Otherwise, I'll just create some. Don't think I did. Yeah. So let's say at a price of 100, people were only going to buy 40 units. At that lower price, they would have bought 30. So that was my change in quantity. I would then divide that by the average. Okay. And now it's a matter of getting this entered into my calculator. Okay. Now I forgot to do one thing, right? In fact, I mixed these up, so sorry. I know that this is always going to be negative because 30 kind of goes with 100, 40 goes with 80. I'll need to take the absolute value. And I've got some other numbers I'll work through here in a second, but this is the general idea. We'll use this equation and we're just plugging in our 2 quantities and our 2 prices. Yeah. Oh, yeah. Yeah, and so honestly, it kind of makes it easier when we do take the absolute value, that even if you do make a mistake, you get the same value, right? Yep. Any questions on this before we keep? Yeah. Yep, at the very end, right? So if you do this calculation and you correctly put the quantities in the right order, you'll get a negative value, right? But then we just ignore that negative sign. Yep. Any other questions on this before we keep moving here? Okay. So just, whoops. Switching, yeah, there we go. So just another example, right? And I kind of color coded this, I don't know, to kind of match up with what that change, what that average looks like, okay? And then I threw in the absolute value. So let's say I had another example where I have the actual prices and the actual quantity. So let's say the price starts out at 6, at that higher price, 15 people or someone wants to buy 15 of this good. The price falls to 4, and as a result, the quantity demanded goes up to 25. How would I calculate my percentage changes? Well, I'll just take whatever that change in quantity was. So here that would be what? 10 divide that by the average quantity. So if I add these up, divide by 2, I get what? 20, if I'm looking at this correct. So, if you want to do this in pieces, right, you calculate the numerator, write that number down, right? So, maybe I plug these quantities in. So I had what? 10 over, and I said the average was 20. So 10 over 20, my numerator would be 0.5. So I write that number down. I would do it this way because when you start to do like fractions divided by fractions in a calculator, what becomes important? Parentheses, right? It's very easy to mess up that order of operations. And so kind of doing it in steps can often, prevent you from making a calculator mistake. Yeah, so you can use other you shouldn't need anything more. And module 2 was, I guess, I misspoke a little bit. We had to take something to a power. But right here, we're just doing division, right, and addition. So yeah, you only need a 4-function calculator. You can use something that's a little bit, has more capabilities. Yep. Any other questions? So I've got what? 0.5 is my numerator. I then look at, okay, what was my change in price? $2. What was the average price? I add these up, divide by 2, be 5. So 2 over 5 is 0.4. And now I have 0.5 divided by 0.4, should get 1.25, right? Now, technically, right, when I was moving, and once again, I flipped these over. The new price was 4. This price was 6. So I end up with, oops, kind of a negative value here. But at the very end, we would take the absolute value, ignore that negative sign, right? So if it helps along the way, if you find a negative value, you can just ignore the negative sign. You don't have to necessarily take the absolute value at the end. Generally, that's how I'll talk about it. But if you just drop the negative sign here when you calculate, you found it was negative, was it 0.4 on the bottom? You could have just used 0.4, right? You can take the absolute value at any point. We're just ignoring the negative signs here, okay? Any questions or anything up here? Okay. All right. I think if there's anything else I want to say before we keep moving. I think we're good. Got 3 different ranges for elasticity. I'll just show them to you here for a second, and then I want to kind of work through something to make them make a little more sense. Okay. So anytime we have an elasticity measure that's less than 1, right, we would say that demand is inelastic. Anytime it's exactly equal to 1, we'd say it's unit elastic. And then anytime it's greater than 1, we would say it's elastic, right? So I'm going to then kind of explain what this stuff means over here. I think I can walk through it a little bit slower, a little bit better by drawing this out for you. And, just kind of writing things down, I think also kind of helps. I went my rant last, not rant, but, neural pathways and writing down things strengthens those pathways as opposed to just listening or watching something. So let's say I had a percentage change in quantity demanded that was greater than my percentage change in the price. Okay? So if we're just thinking about that this elasticity is supposed to measure the responsiveness of consumers to price changes, if there's, say, 10% change in price and the amount that people buying is changing by 100%, we would say that people are very elastic or very responsive, right? So if what I told you is true, the elasticity measure in that example should be above 1. Well, if I've got a percentage change in quantity demanded, and I can kind of put numbers to this just to kind of help prove it to myself. As soon as I, let's say, divide both sides by that percentage change in price, what's this value? Anything divided by itself is 1. So anytime we started out with that percentage change in quantity demanded being greater than the percentage change in price, well, I think intuitively, like, oh, people are very responsive. They're responding by a larger percent than the actual change in the price. If we just rearrange this a little bit, what we find is, oh yeah, here's my price elasticity of demand measure, and it should be greater than 1. Now, I have it written in here technically. I should be thinking about the absolute value. This is once again why we take the absolute value, because it's easier to think about anything greater than 1 as opposed to less than -1, right? If we were actually using the negative value. So it gets harder to talk about. We just kind of care about the absolute value. So if that elasticity measure is greater than 1, that's telling us that we've got elastic demand. That percentage change in quantity demanded must be greater than the percentage change in price. Okay? You can do the exact, and you put the numbers to it, sure enough, 100 over 10 would be 10. Right? Now let's say I have a percentage change in quantity demanded that's less than the percentage change in price. Well, now it's going to be true. Well, how do I get my elasticity measured? I would divide kind of both sides by the percentage change in price. So I now have the percentage change in quantity demanded divided by the percentage change in the price. What does this value become? Anything divided by itself is 1. So we get, whenever we have the percentage change in quantity demanded being less than the percentage change in price, so we could see really large price changes and people don't change how much they're buying, they would be very unresponsive or inelastic. Yep. And sure enough, we rearrange that. When that is true, our elasticity measure will be less than 1. So that's kind of where that comes from. Now, I won't work through this one, but what happens if they're exactly the same? If the percentage change in quantity demand is the same as the percentage change in price, what's my elasticity measure always going to be? 1, right? That was our unit elastic. Okay. So we've got kind of 3 different ranges we can see demand can be: inelastic, unit elastic, or elastic. Okay. Hopefully this kind of helped connect with some of you a little bit better. Sometimes I think starting with the relationship of the percentages and then rearranging to the elasticity can make a little bit more sense than starting with the elasticities and then kind of working towards what must be true about the relative size changes of the percent change in quantity demand to the percentage change in price. So I'll be able to answer that question as we cover a few more topics. It's a good question, and I'll answer it a little bit now, even though it's a little bit out of order. So if I'm selling a good, to say optimal, we have to think about for who, right? So generally, we think about this elasticity of demand, who cares about it? Suppliers care about it a lot because if I'm changing the price, right? If a really small, let's say I change the price of a bottle of water by 1%. And as a result, people just are like, I'm not going to pay for water. I'll just drink tap water. And we see a reduction in the bottles of water bought by like 200%. They're really responsive. You think that's a good or a bad thing for someone selling bottles of water? Yeah, they're selling it for a little bit more, right? Or they increase the price just a little bit. So yeah, maybe they made a little more off each one they sold, but they're now selling way fewer units. That they're going to lose a lot of money in that. So what do companies like? They like it when demand is very inelastic, because then I can change the price by there it is, there you go. Percentage change in price by a lot. I could increase the price by 100%. And what's going to happen? People might only, their response is going to be relatively low. So I'm now selling the good for twice as much, but maybe people only reduce their quantity, percentage change in quantity is only like 2%. So yeah, I'm selling a few less units, but every unit I'm selling, I'm making twice as much money, right? So companies really like it when your demand is inelastic, okay? And we'll talk about some things that are inelastic, and I think this will help make a little more sense here in a second. So one thing we want to be careful with when we talk about elasticities is it's somewhat related to slope, but it's not the exact same thing. It's not 1-to-1, okay? So it's close, but it's not a perfect relationship. So a rule of thumb is the flatter the curve, right? We would say the more elastic demand is, okay? So the flatter the curve, flatter your demand curve, the more elastic demand is. Okay? So we have 5 different classifications. Got some pretty good drawings here, but I'll draw the extreme ones just to really kind of prove this point, and you'll have the slides to kind of go back to and you can kind of look at them. But I think it, once again, there we go. If I was really mean, I would just not put a lot of these slides out there and just do all the work here, but I always want you to have something to kind of look back on, even if you weren't taking notes or you took notes incorrect, you can kind of go back and check. So let's say I had perfectly inelastic demand, perfectly inelastic. What would that mean? That when I see a percentage change in price, how much do people change what they're buying by? They don't change at all. perfectly inelastic. There's no response, right? So if there's no response, I could see different prices. What's going to be true then about my quantity demanded? Well, I probably should have drawn the arrow down here, but that looks kind of weird, right? My demand curve actually ends up being a completely vertical line, because even if I change the price by a large amount, what's happened to the quantity demanded? It's exactly the same, right? Now, is anything truly perfectly inelastic? Probably not. There are things that are very close to being inelastic, like insulin, right? If I'm a type 1 diabetic and they increase the price of insulin, if I want to keep living my normal life, I'm probably going to have to just pay that price, right? I can't change the amount that I need of or any drug, right? If you have a certain milligrams of a drug you need, the price goes up. I mean, that's an example. They are very close to being perfectly, but even those aren't perfectly inelastic, right? If I'm taking something, a drug, and all of a sudden it just becomes too expensive where I can't afford it, there's plenty of people who just stop taking certain medications, right? There is some price at which they reduce their quantity, but nothing's probably truly perfectly inelastic, but things are pretty close, right? So what are some of these things that are, so just to be, I've said it, but this would be perfectly inelastic, because my percentage change in quantity demanded will always be what? If I'm not changing, that would be a 0% change. What's going to be true about my elasticity of demand for a perfectly inelastic good? Well, if my elasticity measure is this, oh, I forgot my triangle there. If this is always 0, it doesn't matter what the percentage change in price, 0 over anything is 0, right? So my perfectly inelastic demand, the lowest possible measure I could see for my price elasticity of demand is 0, no response. Now in practice, we're probably not going to see things that are perfectly inelastic. We're probably going to see things that are close, right? So things that aren't perfectly inelastic, but pretty inelastic, right? They still have an elasticity measure less than 1, are going to look something like this. Well, I'll say my color. So let's say here, I get a relatively large, try to draw this to scale. So you can kind of see here, I've got a percent change in my price that's going to be greater than this percentage change in quantity demanded. So here we think about this, as my denominator. This is my numerator. So if this is smaller, I'm going to have an elasticity measure less than 1, right? So fairly steep slopes would represent a fairly inelastic thing. And then as that slope gets kind of flatter and flatter, we can think about, I'll draw down a separate graph here. Put this right next to it. So let's think about one that's relatively flat. Now I could see a pretty small percentage change in price, but it could result in a relatively large percentage change in my quantity demand. Now my percent change in quantity demand is greater than percent change in price. What's true about my elasticity of demand? Well, this was the numerator. So if I take a number and divide it by something that's smaller than itself, this would be greater than 1. So as my curve is getting flatter, my elasticity measure is getting larger, right? It's representing people are more responsive to even small price changes here. Yeah. So I drew it as a curve. I'll always keep demand linear, right? We can, if we were to go to intermediate, like the next level, we could start to put some curvature to supply and demand. I think I drew it to kind of really amplify the percent changes on the slides. But yeah, I'll always keep demand kind of linear. Yep. Any other questions on this before keep? Okay. Now I didn't draw one out, but we'll kind of use the slides to talk about it because I think it should be relatively, given that, I think we should be okay. So here we already talked through a lot of this, but if I have a perfectly inelastic demand curve, it's going to be vertical, right? My consumers have no sensitivity to price. They're not responding at all. So I could see relatively large percent changes in price, and I say relatively large, any number really. Here I chose 10. But if I'm not responding at all, we said the percentage change in quantity demand was always 0. So my elasticity of demand will always be 0 if it's perfectly inelastic. Now the slope here, it gets kind of weird, and I won't ask you a lot of these, I'm not gonna make you calculate necessarily the slope in a lot of these examples. But if I had perfectly inelastic demand, my percentage change, to find the slope, we need to do what? Change in Y over change in X. So here it would be my change in price divided by my change in quantity. So if my change in quantity is 0, anything divided by 0 is what? It's a weird one. Infinite, right? So anything divided by 0, right? When we're calculating slope, not the elasticity of demand, when we calculate slope, the change in Y would be whatever this change was, divided by a change in X. There is no change in X. So dividing something by 0, it's actually the slope is infinite here. All right. So it's kind of weird. There's a mathematical proof. You could take real analysis. That's a course that if any of you are interested in later on in your career or college careers, it's a fun one. You'd like go down also YouTube rabbit holes about infinity for hours. I have. I don't know if it had any marginal benefit to my life, but I did it, right? So we've got slope and elasticity. You can kind of see here, this is where we don't want to think about them one-to-one, because they're almost like exact opposites here, right? My price elasticity of demand is going to be 0, even when my slope is infinite. And you'll notice, when I calculate a slope, it's the change in Y over change in X. My price elasticity of demand is the exact opposite of that. It's the percentage change in quantity demanded, my X good there, or my X-axis, divided by the change in the Y-axis. All right, so it's not the same thing as slope. Okay? This is where I draw some lines with some curvature to them, but I'll always kind of keep any question I'd ask you linear. So, if I think about inelastic demand, we said it's pretty steep. It's not perfectly inelastic where it's a vertical line, but it's pretty steep. That means that for the same percent change in price, I'm now going to see some percent change in quantity demanded, right? It's going to be smaller than that percentage change in price. And so anytime I take a number that's smaller than another number and I take the ratio, I'm always going to end up with a value that's less than 1. Right? So anytime I have relatively small percent change in quantity demanded, I'm going to get this less than 1 elasticity measure. And, my slope, we're not going to talk too much about it. We're really only going to talk about the slope of the extremes, because there's not a kind of rule that we're necessarily going to dive into in this class in terms of what that relationship is between slope and price elasticity of demand, other than just that as it gets kind of flatter, we're getting more elastic demand. That's all you need to know about that relationship between the slope and price elasticity of demand. So kind of your question earlier, we already alluded to this, right? You know that people got inelastic demand. I can jack the price up and I'm not going to sell that, I'm not going to lose out on selling too many units, right? If you guys don't know this guy's story, you should look. I think it was in Mark is it Scarelli? Scarelli? Yeah, this is an interesting story that we don't have time to dive into, but if you're interested, I think is it Martin? Yeah, Martin. So he bought like the Wu-Tang albums. Yeah, that's how he became famous, and he made all this money. And like I said, he bought like the original Wu-Tang albums, and it's wild, right? It's like a whole Netflix documentary. But anyways, so we keep moving, right? So what if I have perfectly elastic demand? This is the one we haven't covered. So actually there I'm going to end up with a completely horizontal curve. So we said perfectly inelastic. As it becomes flatter and flatter, it's becoming more and more elastic. What would be perfectly elastic if I saw no change in the price, but people bought all of a sudden less of it, right? Or even, we could kind of just think about the smallest, like nothing's truly perfectly elastic. We could think about the smallest percentage change in price could cause people to go from buying a lot to almost nothing. Really large percent change in quantity demand. So here, if I've got my price elasticity of demand, I could see no change in the price. If it was perfectly elastic, people change the amount they buy by something, even though the price didn't change. We're going to have people being very responsive. The price didn't even change when they're responding, right? So this would be kind of our perfectly elastic demand. Anything divided by 0, said earlier, would be infinity, right? So nothing in practice is truly perfectly elastic, but sometimes these extremes can help us to think about the thing in the middle. Perfectly inelastic, I've got like the steepest slope possible. Perfectly elastic, I've got the flattest slope, right? A complete straight horizontal line. Okay? So my slope here would be what? For the change in y over change in x. What's my change in y? So my slope would be 0 for these perfectly elastic domains. Okay? Now, like I said, nothing's probably truly perfectly elastic. I use these extreme points to, once again, help us think about how going from the steepest slope possible, which would have the highest, which have the largest slope with the, would have the highest slope with the smallest price elasticity demand. As I become flatter and flatter, that elasticity is going up and up and up until we get to a completely perfectly elastic demand curve where we now have a price elasticity of demand of infinity. Now, once again, in practice, we're not going to have perfectly flat curves. We'll have relatively flat curves. So I could see, this 10% change in price, a much larger percent change in quantity demanded, so something above that 10%. Anytime I take a number that's larger in the numerator than the denominator, I know that that fraction will always be greater than 1. Right? So anytime I've got somewhat kind of flat curves, I'll end up having kind of an elastic demand curve. Any questions on this before we keep it? Yeah. We haven't talked about that yet, but yeah. And then unit elastic, I won't waste too much time on this. It's just when we have the exact same, a unit elastic curve is going to be something that's pretty 45-degree angle, right? We kind of have these identical percent change in quantity demanded to our percent change in price. Okay. And that was where they're the exact same. We said, what would the elasticity measure have to be? It would have to be 1. So I want to make sure we talk through the determinants of elasticity and then have a little bit of time to kind of work through some of those questions. So let's think about what's going to make demand more or less elastic, right? So if I have more substitutes, so let's say good has more substitutes. So think about something like any type of make and model of car, right? So I'm thinking about, I don't know, a Ford or a Chevy Equinox. It has a lot of available substitutes. So as the price of that good changes, right, people have more options to buy other things. People are going to be relatively elastic, right? So if I have a lot of very similar substitutes, I'm going to end up with elastic demand, a more elastic demand. Because if I now change the price, people are going to just stop using this good and go look for, buy the same exact thing, but a different brand, right? So that's the idea of something that's elastic. It's when there's a lot of substitutes that are very similar to it. Now it works the other way as well. So I always think about things like branding wise when I think about the substitutes, that relationship. If I'm thinking about cereal, if I go to the cereal aisle and my favorite cereal aisle, let's say it's Cheerios, and they increase the price by, even 20%. So now I'm looking at it and it's way more expensive than every other single box in that aisle. What do I probably do? Stop buying Cheerios and get something that's pretty close to it. Maybe some knockoff brand, Kroger brand Cheerios or whatever, right? So something with a lot of brands, and you think about people are going to be very elastic. They're just going to hop to a different brand. It's like the exact same product. Works the opposite way as well. If there aren't a lot of substitutes, well, then I can't be very elastic. I have, let's say, we have very unique things. So I chose like Super Bowl tickets. Like there's not a lot of substitutes for that. So what happens? They change the price. They increase the price a lot. What happens to the amount of tickets they sell? Doesn't change by much. In fact, they sell out like every single Super Bowl. So you would say demand for the Super Bowl tickets pretty inelastic, pretty close to perfectly inelastic. If you change the price a lot, people keep demanding the same amount of Super Bowl tickets. Or anything you think about like unique items. My brother's I don't know, he's like into card collecting and going to all these shows and selling them and everything. And like when you get like one of a kind things, right, where there's like the print there's only 1 out of 1. Well, what happens to the demand for that product? The price can go up a lot and people still really want it, right? Because there's only one. There are no substitutes. Right? Another example that apparently is my example of the day, insulin, right? As far as I know medically, there's not another drug that does the same thing as insulin, right? And so if there aren't other substitutes, we're going to be pretty inelastic. So lots of substitutes, elastic, not many substitutes, pretty inelastic. Any questions on that? I think it's too bad here. the next thing we'll think about is the proportion of your income you're spending on something. So I used my example earlier where I said there was a lot of substitutes for cars, but if we actually look at the demand for cars, it's actually pretty elastic, right? So you don't have a lot of brands to choose from, right? And all of these things, right? These traits, you know, we're just looking at this specific trait, kind of just substitutes. Now I'm looking at just income. People spend a high proportion of their money on, well, instead of cars, let's use houses, right? You spend a large percent of your income on houses. So what do you think when you're making a decision to buy a house versus a bottle of water? How much are you paying attention to the price of the house compared to the bottle of water? A lot more, right? People will haggle. Homes, you know, I don't know what average home prices are in Bloomington. I know they're pretty high, but like, let's say the average home price is like 200,000. I think that's actually lower than what it is in Bloomington, right? People will haggle over thousands of dollars. Like a $200,000 house, when you go to buy it, buyers and sellers will haggle over like $2,000-$3,000. And you're like, why? Because they're really sensitive to price changes. They're spending a lot of money on this, a large portion of their income. They're going to really be sensitive to changes in that price. So anything you spend a high proportion of your income on, you're going to be very elastic, right? People you'll see on the market, they'll lower out a $400,000 house by $10,000, and all of a sudden it went from not being nobody wanting it to all of a sudden everybody wants it, right? So it's very elastic when it's a high proportion of your income. Now, if it's a small proportion of my income, I'm looking at like a bottle of water, right? They could increase the price of this bottle of water if I really was thirsty and I needed water. It'd be $1 or $2. That's a really large percent change in price. I'm probably still going to just buy it, right? If I'm thirsty, I'm at a gas station, I need something to drink, I'm just going to buy whatever the bottle of water, cheapest bottle of water, whatever the price is. They could change the price by quite a bit, and I'm still going to keep buying the same amount. So anytime you have a small proportion of your income spent on something, there we're going to be pretty inelastic, right? So I feel like, fountain drinks that people are going in, they change these all the time. Like they'll run specials on things where it's like 89 cents, and then the regular price is $1.59 or whatever it is. That's a large percent change in price. People probably, my imagination is they don't sell a whole lot more or less of those fountain drinks, right? If you go into a gas station and see those. Right? So this is kind of the relationship of the proportion of income to elasticity. Okay? Any questions on this before we keep moving? I think we've got one more here, which is the length of time to make a decision. So we're thinking about buying things, right? For example, if I'm really thirsty, I walk into a gas station, I need to get something to drink, I don't have a lot of time. What do you think? Am I going to be more or less elastic to price changes? Less, right? If I don't have any time to find any substitutes, you can almost think about time as connected to substitutes. The less the time I have, and I'll go to the more time one in a second, the less time I have, I can't find as many substitutes. If there aren't many substitutes, what does that make my demand? More inelastic. Right? I can't be as responsive. I don't have more time to be able to respond to that price change, right? So we think about things that are more elastic, right? I have more time. So in the example of like buying a home, another reason why price elasticity demand for homes is relatively high is because people have a lot of time to kind of shop around. Same thing with kind of cars. Another thing that makes their demand a little bit more elastic. People can shop around for different prices, right? They can find more substitutes. So the more time you have, the more substitutes you can find. You can find kind of a better deal from someone else. So it's going to make your demand for the product more elastic. Right? So more time, you can find more substitutes, makes your demand more elastic. Kind of the reverse true if you have less time. Questions on this before we keep moving here? Okay. So I have some examples here. We can kind of think through like which of these make sense. So I don't know. I grabbed these from some government agencies. So matches, or for whatever reason, like I'm guessing because like if you need matches, like the price is relatively low, but large percent changes in price, you probably still, well, I need matches to light whatever I need to light, right? And so ends up being fairly inelastic. Or yeah. So this is an interesting one. So they were looking at people who had to make decisions to buy an airline ticket where there was a short window. So the date at which they were buying the ticket was close to like the date that they needed it. Very inelastic, right? If I have to be to Chicago tomorrow, I can't be very responsive to the current prices of those tickets. I've got to get the ticket, right? So in the short run, we see pretty inelastic for airline tickets. But in the long run, when we look at when people have a much longer day, like I'm planning for a trip that's a couple months from now, what do I do for the next couple months? Continuously check on airline prices, right? I don't buy any, right? I'm very elastic. I have more time to make my decision. I look for available substitutes and then I hopefully find kind of the best deal over that time frame that I have. So that's a really good one from this that kind of highlights that determinant of demand. Kind of interesting is like private education, so like private schools, it's almost unit elastic. What are some other things? So I said, you know, automobiles, right? Brand new automobiles. If I'm spending a large proportion of my income and I have a lot of time to make this car purchase decision, right? That's both those things are going to feed into me being a lot more elastic, right? There's also a lot more available substitutes, right? So I'm a lot more elastic, and that ends up having the highest elasticity of the goods that I have up here. I also put one up here because I think it's kind of interesting, but what's also inelastic, not just like tobacco, but like drugs in general. You know, prices of drugs can change, and we see that people keep using the same amount, right? If you're addicted to heroin, you're going to pay whatever you need to pay because you're addicted to heroin, right? And so you can see large percent changes in price, no percent change, or a small percent change in the quantity. Here's just some other ones. I don't know, some other interesting. I think this one was just alcoholic drinks. I thought this one was, it's kind of amazing how even within the same category, like mezcal and things that are a little bit more like unique, there's not as many makers of them. We get like a lot higher elasticities, whereas like you're talking about like things that are, there's tons of different substitutes here, tons of different types of scotch. There you end up with like really, really small elasticity measures. So even within the same good, the different traits of the products in that category, some of them can be, demand can be kind of inelastic, and some of them can be a little bit more elastic, right? All right, so I've already kind of mentioned this. These are not exactly the same. We've kind of talked through the relationship. I want to make sure we have enough time though. Let's kind of walk through some of these questions. So once again, I'm just using Top Hat to present these questions to you because I already had them written in Top Hat. You will need to go on after today's class down to what will be released after class, which is this 917 class participation questions assignment, and then answer these questions. So it's my way of incentivizing you to come to class because in the recordings, I'm cutting out this portion. So in fact, I'm going to stop talking here.